Okay, this is refining crude oil. For the large-scale fractional distillation, okay, this is just like a factory, okay, a large factory. It's carried out in oil refineries, okay, and this tower is fractionating tower. Okay, we have a video. We take a look of the video.
Crude oil is a mixture of hundreds of hydrocarbons. To use crude oil effectively, the different hydrocarbons in the crude oil have to be separated by a process called fractional distillation. Now let's see how fractional distillation is carried out. On a large scale, fractional distillation is carried out in oil refineries. In the oil refinery, crude oil is first heated to about 400 degrees Celsius in a furnace. Hydrocarbons with lower boiling point vaporize, while those with higher boiling points remain as liquids. The hot crude oil is then pumped into a fractionating tower. The vapor portion of the crude oil rises up the tower, while the liquid portion flows to the bottom of the tower. The liquids collected at the bottom of the tower are hydrocarbons with boiling points higher than 350 degrees Celsius. They include fuel oil, lubricating oil, and bitumen. They are piped to storage tanks for further processing. The vapor of crude oil rises up the tower through these bubble caps. Each level of the fractionating tower is kept at a particular temperature. The higher levels are cooler than the lower levels. When the vapor of crude oil rises up the tower, different hydrocarbons in the vapor cool and condense at different levels. Hydrocarbons with higher boiling points condense at lower levels, while those with lower boiling points condense at higher levels. These condensed hydrocarbons are then piped to storage tanks for further processing.
Okay, we take a look of the fractionating tower. At first, for the tower, lower part is higher temperature, and for upper part is lower temperature. And at the beginning, the crude oil will increase the temperature, raise the temperature in the furnace here. The temperature is very large. That is about 400 degrees Celsius. When the crude oil is heated here, 400 degrees Celsius. And then, for the hydrocarbons, some very large size hydrocarbons, the boiling point is very high. So, even 400 degrees Celsius, they are still liquid. So, here, even 400 degrees Celsius, they are still liquid. They will go down as liquid. But for large size, medium size, or small size molecule, this temperature is too high for them. And then they are no longer liquid. They will vaporize. They will become gas. And then they will go up to the tower. Okay, so first step. After the 400 degrees Celsius, the very large size molecule, they are still liquid, they will go down and then we will collect here. Okay? But for the large size, medium size, small size molecule, they will go up. Okay? If the temperature is low enough, they will condense, become liquid, and then they will go to the right hand side, and then they will leave the tower, and then we will collect. So for the different size molecule, okay, very small molecule, we will collect at the top. Okay, medium size, larger size. If the size is larger, we will collect at the lower part. Okay, and this is the very large size molecule. Okay. So step by step, if the hydrocarbons is very small or medium size, when they here heat to 400 degrees Celsius, they will become vapor and then they will go up. But at the lower part of the tower, the temperature is still high enough, so they will stay as gas and go up. Okay, and then this medium size, here, the temperature is cool enough, low enough, and then they will condense to liquid and then leave here. For the small size, they need a lower temperature and then they will condense to liquid and then leave here. But for the very small molecule, they are still vapor and then they will collect at the top of the tower. Okay, they are still gas. And then you will see that different size molecule we will collect at the different height of the tower. But for the large size and quite large size, after here 400 degrees Celsius, they become gas and then will go up. But as the molecule size is large, their boiling point is higher, and then this will be cool enough for them to condense to become liquid, and then we will leave the tower. Okay, so remember, lower part is higher temperature, upper part is lower temperature. And for the very large size molecule, very high temperature, okay, they are cool enough, they will condense, become liquid, and then leave the tower. Okay, we will talk about the major uses of crude oil. For the very small molecule, this is liquefied petroleum gas, and in short form we will say LPG. Okay, and their boiling point is below 40 degrees Celsius. Okay, what will we use? They are fuel for tanks and public libraries and household fuel. We use these for cooking or to make hot water for shower or bath. Okay, a little bit larger size molecule, and the boiling point is 40 to 70 degrees Celsius. That is petrol. Petrol is fuel for motor cars. Okay, increase the size of the molecule and then the boiling point also increase. That is naphtha. Naphtha is a raw material for producing tank gas, plastics, and other chemicals. So this is a very important raw materials. Okay, larger size, higher boiling point, 170 degrees Celsius to 250 degrees Celsius. This is kerosene. Kerosene is fuel for airplanes. Okay, larger size molecule, higher temperature of boiling point. This is diesel. Diesel is fuel for heavy vehicles. And then for very large size molecule, the boiling point is over 350 degrees Celsius. They are fuel oil, lubricating oil and wax, bitumen. For the fuel oil, when burning, the air pollution is very serious, so we cannot use the fuel oil for vehicles, for cars, for bus, something like that. We only can use the fuel oil as fuel for ships and power stations. Lubricating oil and wax. This is oil for lubricating machines. So the moving part, it will move smoothly. And wax for making candles. Bitumen, it is for covering roads. Okay, so for the major use of crude oil, that is as fuel or as raw material. As fuel, it is used for transportation, okay? We already talked about. And as fuel, it may be for domestic heating, okay? We cooking. Or for generating electricity, okay? Fuel oil is for the power station to generating electricity. And as raw material, naphtha, that is raw material for making different chemicals. It may be for plastic, for making detergents, or for making paints. Okay, conclusion. Crude oil is an important source of fuel and of raw material for making various products. So crude oil is very important material. Now, finish your book. Actually, you can refer to the book page 74. Okay, different boiling point, we will have different fraction from the crude oil. Okay, this is quite easy. Okay, last question. What is the name for the process? So in diagram in question 1, and the process is fractional distillation. Okay, we finish here. Thank you.